Assalamualaikum and good day everyone. First of all, I'd like to thank the organizer of this conference for making this valuable opportunity for a presenter. Let me start by introducing myself. I am Zakiah binti Ainul Kamal, a PhD student of Geoscience at University Malaysia Kelantan. I am here today to present my paper entitled The Investigation of Seawater Intrusion in Coastal Aquifer of Kelantan, Malaysia, using geophysical and hydrochemical technique. This is the quick outline of my presentation that I will be going through, and my presentation will take about 10 minutes. First of all, I'd like to give you an overview of groundwater. What is groundwater? Groundwater is the water found underground in the cracks and spaces in soil, sand, and rocks. It is one of the world's most valuable natural resources, which is always available and renewable and low cost. Like other regions and countries around the world, Malaysia is also reliant on groundwater, especially in Kelantan. Groundwater supplies more than 60% of the public water supplies. The groundwater quality is based on physical properties such as color, odor, turbidity, and chemical constituents. Along with the growing population, industrial activities and agricultural activities, it has caused increase in the water demand, and this has caused overpumping of the groundwater. This high rate of water abstraction causing the movement of seawater accelerate fast towards the land, which will cause the mixing of groundwater and seawater. Overexploitation of groundwater in coastal aquifer results in a decrease in groundwater level, whereas saline water moves into the freshwater zone. This phenomena is known as seawater intrusion. Seawater intrusion is a phenomenon caused by movement of seawater into the freshwater coastal aquifer, either by natural or anthropogenic means. Seawater intrusion is a widespread and a common problem in developed coastal aquifer system. Therefore, to assure fresh and uncontaminated water to all living community and to save our prosperous environment, it is necessary to manage our water resources. There are several methods that can be adopted for studying salinization of groundwater or seawater intrusion. In this study, the purpose or the objective is to assess the extent of seawater intrusion in the coastal aquifer in the northern part of Kelantan using electrical resistivity method and hydrochemical analysis. Let's now look at the next slide, which shows the map of the research area. This is the map of my research area. This map is showing the location of the research area. The research location is located near to the coastal, where distance from the coast is around 0.5 to 2 kilometers. Here. The location of the resistivity survey and groundwater sampling includes area in Tumpat, Kota Baru, and Pekalan Ceper, which is in the Kelantan River Basin area. This is the Sungai Kelantan. As we can see here, there are purple and red dots. The red dots representing the groundwater sample location, and these purple dots represent the resistivity profile. Next, in methodology. In this study, resistivity survey was performed using ABEM thermometer. Electrical resistivity method is useful for understanding aquifer structures and geology in the subsurface condition. Resistivity survey have been widely used to overcome groundwater problems such as salinity, pollution, groundwater conservation, and many others. Resistivity survey is one of the popular methods because, first, it is a non-invasive technique which provides the information about subsurface and aids in identification of seawater intrusion. Second, it is relatively inexpensive, and electrical resistivity are the intrinsic properties of groundwater chemistry that are readily interpreted in terms of the degree of groundwater contamination. In this study, resistivity profiling was carried out in 5 profiles perpendicular to the coast. Each profile is in length of 200 meters with Schlumberger and pole dipole configuration. Groundwater samples also taken from several wells in the study area for hydrochemical analysis and in situ parameters. For hydrochemical analysis, atomic absorption spectrometry (AAS) has been used. For in situ parameters, we test for pH, electrical conductivity (EC), temperature, salinity, and TDS using YSI 5556 MPS multi-probe parameter. I would like to show some of the picture during our resistivity survey. Now let's move to the study result. This is the image of my 2D resistivity profile. Five resistivity profiles has been carried out in this study with different location. However, here in this presentation, I only show 4 resistivity profiles. These resistivity profiles then was compared with the water quality parameter. As we can see here in the 2D models, the penetration depth is vary around 30 to 60 meters below the surface. The resistivity profiles is zoned into 3 sections, which is low, medium, and high resistivity value. In low resistivity profiles or zones, the values are less than 1.5 ohm meter. In medium zones, the values are from 5 to 10 ohm meter, and the high resistivity value is more than 15 ohm meter. As we can see, in these 4 resistivity profiles, the low resistivity value can reach down to 0.1 ohm meter. The presence of low resistivity zones, like here, lower than 1.5 ohm meter, can be interpreted as indicating the presence of saline water because fresh water, such as groundwater, generally has a resistivity of between 20 to 100 ohm meter. The presence of the saline water can be seen at the uppermost zones of the aquifer system. Bear in mind that the location of the resistivity is located near to the river or in the estuary areas. These low resistivity values indicate that the ionic concentration in water is high or increased. The more ions that are present, the higher the conductivity or the lower the resistivity of the water. This indicates that the area is saline because salinity is a strong contributor to conductivity. These low resistivity zones also correspond with the in situ parameter reading. High electrical conductivity EC value is taken at the sampling point number 1, which is near to the resistivity profile number 1, and sampling point number 2 and 5, which is value of 989.9, 1979, and 887 microsiemens per centimeter respectively. Simply put, the EC value is the salt concentration in solution. EC value more than 100 is considered as an area that has seawater intrusion symptom. For the total dissolved solid, TDS, value in sample 2, it has a value of 1061 milligram per unit volume of water. This value exceeds 1000 mg per liter, which is the TDS value of fresh water by 61, means the amount is just slightly small, exceed the fresh water value. The major ions in seawater are chloride, sodium, sulfate, calcium, potassium, bicarbonate, and bromine. Many of these ions are also present in the freshwater zones, but in much smaller amount. As we can see in this table, the element concentration are in low except for chloride concentration in sample number 2 with 1288, and sodium concentration in sample 2 also with 605.4. The high chloride, TDS, and EC in the sample number 2 indicate that the area will contaminate due to the intrusion of seawater. In this study, the finding shows the influence of saline water mixing with fresh water in the study area are in minimum extent, except in area sampling 2. However, the value is slightly higher and does not indicate any anomalous reading. The groundwater are much not affected by the contamination process or the saline water, as the low resistivity value is only present at the shallow part of the study. To conclude, the presence of saline water can be associated with direct intrusion of seawater into the groundwater water system, or it can be contributed from the infiltration of seawater through the rivers or canals during high tides into the coastal plain. I'm now approaching the end of my presentation, but before that, I would like to tell you about the future works or the research way forward. First, this research can be made in details using the stable isotope analysis to know deeper about the interface reaction of the water, and next is to do systematic soil sampling for chemical analysis to detect seawater intrusion. So that's all from me. Thank you for listening and have a good day. Thank you.